My name is Tanisha Nagwani, roll number IC2K2393 from MCA 5 years course 5th SEM B section. In this video, we will solve the 5th semester and semester examination from question number 3 to question number 6. So the question number 3 is A part is explain the data bringing process with a suitable example, and the B part is what is the difference between errors and artifacts in data cleaning. Explain any two imputation techniques. So the data bringing, also known as data mining or data preparation, is the crucial process for transforming raw, messy data into a clean, structured and usable format that is suitable for analysis, visualization, and machine learning models. It typically consumes the largest portion of time in a data science project. Now, the steps are discovery and profiling. So, it is the understanding the raw data by inspecting its structure, identifying sources, and reporting on its quality. Then, examples are a quick check for the purpose date column reveals that it is stored as a string instead of a date time format, and the state column contains the inconsistent entries. The second is structuring or transforming. So the description is reshaping the data to meet analytical requirements, such as pivoting rows to columns, splitting fields, or merging multiple data sets. Example, merge the separate customer demographics dataset with the transaction history dataset using the common customer ID field. The third is cleaning, that is fixing errors to improve quality. This improves handling missing data, correcting typos, and removing duplicates or irrelevant records. The task is example is remove duplicate customer records based on identical customer ID and purchase date combination. The fourth is enriching or feature engineering. It is adding value to the data by creating new features or integrating external information to deepen insights. Then the examples are create a new feature called customer age by calculating the difference between the current date and date of birth column. The fifth is validating and publishing. So the description is checking the final dataset against defined rules to ensure consistency and quality. The final prepared dataset is then stored for use. The example is to validate that all values in the purchase amount column are positive and within a reasonable business range. Load the final clean data into a data warehouse for the analysis team. Now we'll see the difference between error and artifacts. So error is data error and artifacts are data artifacts or statistical artifacts. So the source for the error is information fundamentally lost or corrupted during acquisition or entry. And the source for artifact is systematic problem introduced during data processing, analysis, or cleaning itself. Then the recoverability for error is often irretrievable. The original correct value is lost, and in artifact, it is generally correctable if the source of the processing issue is identified. The nature of the error is random or intermittent issues. Example, a typo, a server crash, losing a transaction. And the nature for artifact is consistent systematic problem. Example, a faulty sensor. Then examples in error is a clerk accidentally types 2005 instead of 2050 for a product price. And in artifact, the example is a cleaning script mistakenly converts all bank values to zero for a continuous variable, creating an artificial spike at zero interdistribution. Now we'll see the two imputation techniques. So the imputation is the process of replacing missing data points with situated values to maintain the dataset's completeness and integrity, which is a key part of the data cleaning process. The first is mean median imputation, and the second is k nearest neighbors, that is KNN imputation. So the first the first is mean median imputation. So it is a straightforward and common method for handling missing data. Particularly for numerical features, the core idea is to replace any missing value in a column with the measure of central tendency calculated from the observed non-missing values in the same column. Especially mean imputed is employed when the data is roughly normally distributed as the average provides a good estimate of the center. However, if the data is highly skewed or contains significant outliers, the mean can be heavily influenced, leading to a bias substitution. In such cases, median imputation is the preferred technique because the median is resistant to extreme values, offering a more robust estimate of the typical value. Then the k nearest neighbors, that is KNN imputation, are the k nearest imputation is a more sophisticated and more non-parametric method that leverages the correlation between features to estimate missing values. Instead of relying solely on the column itself, KNN finds the k most similar data points, the neighbors, to the observation containing the missing value using a distance metric like Euclid distance calculated across the other non-missing features. The missing value is then filled based on the neighbors. For a numerical feature, the average of the neighbor value is used. For a categorical feature, the mode is used. Then we will read the fourth question. The A part is explain any four common feature engineering technique for contiguous or categorical data. And the B part of the question 4 is for the data set from 12 to 30, compute mean, median, mode, and standard deviation. Explain when to use each measure. So, feature engineering is the process of using domain knowledge to transform raw data into features that better represent the underlying problem to the predictive models, improving model accuracy and interpretability. Then the four common feature engineering techniques for contiguous or categorical data are: first is one hot encoding for nominal categorical data. So one hot encoding is a fundamental technique used to convert non-numeric nominal categorical variables into a numerical format suitable for most machine learning algorithms. Since many models, especially linear ones, cannot directly process string labels and would incorrectly infer an ordinal relationship from simple integer mapping. Then this method is used to create a safe binary representation for a feature with k unique categories. K new binary columns are created. Each observation receives a new value of 1 in the column corresponding to its category and 0 in the all others. For instance, a category column with values Paris, Tokyo, and London is replaced by the three column City Paris, City Tokyo, and City London, with a row for a Parisian customer would have 100. The second feature is feature scaling, which is normalization and standardization. So feature scaling is essential for continuous numerical data, particularly when using distant weight algorithm in k nearest neighbors KNN. K means clustering or optimization algorithm like gradient descent used in neural network and linear regression. The goal is to update thereby ensuring all features contribute proportionally to the result. Two common methods are min-max scaling, which rescales data to a fixed range, usually 0, 1, and standardization that uses z-square scaling, which transforms the data to have a mean of 0 and a standard deviation of 1. The third is discretization, that is binning. So, discretization of binning is the process of converting a continuous numerical feature into a set of discrete order categorical bins or intervals. This technique can be valuable for handling highly skewed data, reducing the effect of minor measurement errors or linearing non-linear relationships, especially when used with models like decision trees. Methods for binary binning include equal weight binning, which divides the data range into intervals of equal size, and equal frequency binning, which divides the data such that each bin contains roughly the same number of data points. For example, a continuous income feature can be binned into category with like low, medium, and high, which can often simplify the model. The fourth is date and time feature extraction. So in this, when dealing with raw time series or data time variables directly using the timestamp is really helpful for a model. Date and time feature extraction involves decomposing a single date time column into multiple highly predictive feature by leveraging domain knowledge. Useful feature extracted often include the day of the week, example 0 for Monday and 6 for Sunday, month, year, and quarter, whether the date falls on a weekend or a time elapsed since a significant event. For instance, from a login column, one might extract the date of week to capture weekly purchase patterns to or calculate days since last purchase to estimate customer churn risk, providing the model with meaningful temporal content. Then we will calculate the mean. So the mean is calculated by denoted by x bar. So it is the sum of all the values divided by the number of values. So it comes out to be 122. Then we will calculate median. So the median is the middle value of a data set which is when it is ordered. So the middle value comes out to be fourth position, that is 15. The mode is most frequent values, the value that appears most often in the data set. So there are two values, that is 12 and 15, that appears twice. So mode becomes 12 and 15. The data is binomial. Then the standard deviation. So the standard deviation measures the amount of variation or dispersion of a set of values from the mean. So in this, we will first calculate the squared difference from the mean, approx 17.443 for each xi. Then we will calculate the variance of that is x squared. Then we will calculate the standard deviation, that is s. So in this way, this is a table, and in this we will calculate the standard deviation. Then we will calculate the variance using this formula, which will be approximately equal to 39.28. Then we will calculate the standard deviation, that is under root of variance, which comes out to be 6.24 or 6.27. Now, when to use these? So first is when to use mean. So when the data is symmetrical and does not contain significant outliers, used for statistical inference and modeling. Median is used when the data is skewed or contains significant outliers, used for income, house prices, or skewed distribution. Then mode is used when analyzing categorical or discrete data, or when the goal is to find the most frequent or popular item or category. Then standard deviation as a measure of variability or spread, especially when the mean is used as a measure of central tendency. Moving on to the question fifth. So the question fifth A part is distinguish between parametric and non-parametric models. The second is supervised and unsupervised learning. And the B part is with reference to text mining, describe accuracy, precision, recall, FN score, and illustrate their computation using a confusion matrix. So the first feature is assumption, and the parametric model is makes strong assumption about the functional form of the relationship between features and the target, often assuming the data flows as a specific distribution. Then in non-parametric models, it makes minimal or no assumption about the functional form of the relationship or the underlying data distribution. Then in structure, so in parametric models, structure is like the model structure is fixed and summarized by a finite number of parameters. And in non-parametric model, the model structure is flexible and often grows with the size of the training data. Then complexity. So parametric model generally have simpler and faster to train, highly interpretable. Then non-parametric models are generally more complex and slower to train, often less interpretable. Then the data efficiency is requires less data to achieve good performance, provided by the assumption about the data are correct in parametric models. And in non-parametric models, it requires large amount of data to accurately map the functional form. Then the examples are linear regression, logistic regression, linear discriminant analysis, that is LDA in parametric models. And in non-parametric models, we have KNN, then decision trees, support vector machine, and especially with nonlinear kernels and neural networks. Then we will see the difference between supervised and unsupervised learning. So supervised learning uses labeled data Each observation has both input feature and a corresponding output label or target variable. Then in unsupervised learning, it uses unlabeled data. Observations only have input features with no corresponding output variable. The objective of supervised learning is to learn a mapping function from input to output so that the model can predict the output for new unseen inputs, and in unsupervised learning to infer the natural structure or patterns in the data such as grouping, clustering, or dimensionality reduction. Then key tasks are classification and regression of supervised learning, and in unsupervised learning we have clustering and dimensionality reduction. Then examples of supervised learning are predicting customer churn, image classification, forecasting skills, and in unsupervised learning we have identifying cluster segments, finding anomalies, and compressing data features. Now the confusion matrix. So the confusion matrix is a specific table layout that allows visualization of the performance of an algorithm. Typically, in supervised learning, it compares the actual target values with those predicted by the machine learning model. So, the predicted positive, actual positive and predicted positive makes true positive. Predictive positive and actual negative makes false positive. Then predicted negative and actual positive makes false negative. And predicted negative and actual negative makes true negative. So the metric of that is accuracy, precision, recall, and F1. The formulas are given here. Accuracy is written as TP plus TN upon total. Precision is TP upon TP plus FP. Recall is TP upon TP plus FN. Then F1 score is 2 into precision into recall upon precision plus recall. The description about accuracy is the overall proportion of total prediction that were correct. Then in precision, the description is measures the proportion of positive predictions that were actually correct. The recall description is measures the proportion of actual positive instances that were correctly predicted. And in F1 score, the harmonic mean of prediction in recall, it is a single balance metric that is particularly useful when you need to seek a balance between precision and recall, especially with imbalanced classes. Now we will calculate the accuracy, precision, recall, and F1 score. So we will take these values of the data, and in the formula discussed before, we will put all these values in that. So in this way, we will get all these values. Moving on to the question 6. So question 6 A part is how are missing values handled? Suggests three approaches, and the B part says explain logistic regression and the use of logistic function to calculate the probability of a class for a given input example. So missing values are a common problem in real world data sets and can significantly impact the performance and reliability of machine learning model. The approach to handling them depends on the nature of the data, the proportion of missingness, and the model being used. So the three approaches are deletion. First is deletion method. So deletion method involves removing data points or feature that contain missing values. The simplest form is list-wise deletion, where an entire observation row is discarded if it has any missing data. It is suitable only when the percentage of missing data is very small and the missingness is assumed to be completely random. The second is simple imputation. So, simple imputation involves substituting the missing value with a computed estimate from the available data in that feature. This is often done using a measure of central tendency, the mean for continuous non-squid data, the median for squid data, or the model for particular data. Then the third is indicator variable method. So the indicator variable method is a predictive approach where the missingness itself is treated as valuable information for a feature with missing values. You first impute the missing values with a single placeholder and then create a new binary column. This new column is set to 1 if the original value was missing and 0 otherwise. Now the logistic regression is statistical model used for classification tasks. Despite its name suggesting regression, it is a linear model that uses a complex function, the logistic function, to estimate the probability of a binary outcome. Example 0, 1 or yes or no. Then the linear combination, first is linear combination. So the model first calculates a linear combination of the input features, that is x, and its corresponding weights, that is coefficient of beta, similar to linear regression. So the formula comes out to be beta naught plus beta 1 x1, then beta 2 x2 plus till beta and xn. Then the second is the logistic function, that is sigmoid. So this linear result sigmoid is then passed through the sigmoid function, that is sigma. The sigmoid function is an S-shaped curve that maps a real number input, that is sigmoid, to a value between 0 and 1. This is the formula of logistic function sigmoid. The third is classification. So if the resulting probability P is greater than a chosen threshold, usually 0.5, the observation is classified as 1. Otherwise, it is classified as 0. Calculation for the class probability using the logistic function. So given model parameters are intercept, that is b naught, that is minus 1.5, coefficient is x1, that is beta 1 0.8, coefficient of x2, that is beta 2, that is 1.2. Given input examples, x1 is equals to 2 and x2 is equals to 1. Then the first step is to calculate the linear combination. So in this way, we will calculate and we will put the values in this, and we will calculate the linear combination, so which comes out to be 1.3. Now the step 2 is apply the logistic sigmoid function. So the value sigmoid is 1.3 is passed into the sigmoid function to calculate the probability P of the observation belonging to class 1. So we will put the value in this. So which e to the power minus 1.3 is approximately equal to 0.2725. We will put all these values in this. Then the P of class 1, that is probability of class 1, comes out to be approximately equal to 0.786. So it was all about question 3 to 6. We will solve the rest questions in the next part of the video. Thank you.